So for the do now, I already wrote in the definition because it's based on the last note. So that's supposed to be review. The only thing I added on the right-hand side is that some like to replace the delta x by h. Sorry, my handwriting is terrible. Instead, because it's visually confusing to have x plus delta x and think of delta x as a separate variable. So some people like using h. I'm okay with that. Either one works, okay? As long as you realize that h represents the change in the distance along the x-axis, I'm okay with that. All right, looking at the next one then, it's asking you if, let me scroll this up if it'll let me here. If you wanted to generalize the slope formula of the tangent line of the function f of x for any value x, not just at c, but for all x's on the function where the change in x is represented by delta x, what would your formula then look like? So I want you to try and think about it for a minute, pause the video, write that down. And I'm going to pause here. So the key for this one here is that instead of having it at the point C, where x is equal to c, we are then going to generalize for all possible values for x. So instead of writing c, we're going to write x. It's the general form. So here, we're going to replace the c by an x, like that. So it generalizes it. It lets us find the formula for the slope of the tangent line at any x. So let's try and apply that. In question 3, it's saying use your generalized formula in 2 to help you find the slope of all the values for x, or all the values of x in the function f of x is equal to x squared, and show your work. So you're going to hit pause again and give it a shot. So I put in all of the work that I wrote out. There's a couple of things I want to point out. First of all, I did on the side, just so you could follow along, that here, all of this is f of x plus delta x. I wrote the work on the right-hand side just so you could see where it came from. I substituted in x plus delta x in the x squared function and then expanded that out to help me simplify this. And then the two x squares ended up canceling out. And I could then in the numerator factor out the delta x, because at that stage, right here, let me highlight right here that I'm highlighting right now. At this stage right here, that is indeterminate form. If I tried to take the limit, it would give me 0 over 0. So it's one of the indeterminate forms. So let me, oops, get rid of that. So we have this so far. And I can factor out a delta x, and the delta x's cancel out. Now, I've noticed in some of the free response, some of you are either leaving limits in too long or taking the limits out too early. Right now, I still have a delta x in it. If I'm at this stage right here where I'm highlighting, there's still a delta x in it. Same here, there's still a delta x in it. But once I perform the limit, in other words, as delta x approaches 0, that means the delta x essentially drops out and becomes 2x. The limit is done. You shouldn't write the limit for this one, for the last piece of this, because I have performed the limit already. So it needs to have the limit until you no longer have a delta x in it. All right, let's see if this makes sense though. It's saying, oh, hang on, you end up with something in it with a variable in it. If I looked at the graph of x squared, horrible picture, but just be patient with me. I'm going to draw this the best I can, like that. And you thought about this. If I took the slope over here with the negative x values over here, along here, at different points of tangency, does the slopes vary? In other words, are the slopes constant, have the same value everywhere, or do they change? In my case, I can see, on the left-hand side, on the left of the y-axis, we have negative slopes, then they change to positive slopes. So there's definitely a variation in the slope values that I'm going to get. So therefore, when I write the formula for all of the slopes, it will have to have a variable in it because it varies. That's where, by the way, the word for variable comes from. It's something that varies, okay? So now we should be able to find, based on the formula I just found in here, it's 2x for the slope of the tangent line. I should be able to find it at different values of x. So it allows us to find a whole bunch of slopes all at once instead of just at one point. Now try and do 4. Pause the video and then you can check your answer afterwards. So here are the values that I'm getting for part 4 of this. I just substituted each of the x values in for our formula for the slope of the tangent line at each of those x values.